All right, moving on to page 3 of the review packet. We are just about through this. So number 12 says an annulus is located between a circle of radius 5 centimeters and a circle of radius 7 centimeters. What is the area of the annulus? So remember, an annulus is kind of that tire shape. Okay, so the small radius is 5, the big radius is 7. It's going to be the big minus the small. So the area of the big circle is going to be 49 pi. The area of the little circle is going to be 25 pi. So in the end, I'm left with 24 pi centimeters squared left over. Number 13 is really the same question. A couple kids get confused though because of this 10 on top. That can really translate right down here. So that means the radius of the big one must be 5. So again, it's going to be big minus small. 25 pi is the big. The radius of the little guy is 4. So, or it's 2, excuse me. So the area is going to be 4 because 2 squared is 4. So in the end, I end up with a total of 21 pi centimeters squared. And the reason you have to subtract them, it's like you're taking the area of the whole circle, but you're cutting out that little one because it's not shaded anymore. So you have to subtract the big one from the small one, or the small one from the big one, excuse me. All right, moving on to some more circles. Find the radius if the area of the sector is 50 pi centimeters. So the way I look at this, I like to do it the proportion way. So first of all, sector is always going to be the shaded region, so I need to find the angle that makes the shaded region. And in this case, it's going to be 240 degrees. So when I go to start setting this up, I'm going to do 240 out of 360, because that's the shaded part over the whole thing, is equal to the area of the shaded, which is 50 pi, because it tells me the area of the sector is 50 pi, over the area of the whole circle, which in this case I can't find because I don't know the radius. So I'm going to put pi r squared for the area of the whole circle, because once I find that radius, I could find the area of the whole circle. So I'm going to cross multiply. I get 240 pi r squared equals, I think that's 18,000, but I'm not sure. It is, okay. 18,000 pi. And divide by 240 pi. And I'm left with r squared equals, the pi's are going to cancel. R squared equals 75. Last step, square root. And I get 8.66 centimeters for my radius. Number 15 is one of the trickiest problems on here. It was actually from one of your old worksheets, except they forgot to put this information in, so you couldn't do it. So the radius of the small one, it says, is r. Little r is 8. Radius of the big one is 10. So your first thing is, I always like to say, all right, find the area as if the whole annulus was shaded. So we know how to do that. That's the big minus the small. Big guy is 100 pi. Little guy has an area of 64 pi. Subtract them, I'm left with 36 pi for that blue shaded region. What I do know from the problem, and this should be 10 pi, didn't show up. What I do know from the problem is that the area of just that gray region is 10 pi. So I'm going to set this up as, I don't know what the angle is, but I know it's going to be out of 360, is equal to, I know that the shaded part is 10 pi. And if I were to pretend the whole annulus is shaded, I know the area of the whole annulus is 36 pi. So again, the angle of the annulus over the whole degree measure is 360 equals the shaded part of the annulus over the whole annulus, which is 36 pi. Cross multiply, I get 36 pi x equals 3600 pi. Divide by 36 pi. Left with x equals, pi's cancel, 3600 divided by 36 leaves me with x equals 100 degrees. Right? Now, you could do this another way. You could find the area as if this whole thing was shaded, and then subtract off this guy. That takes a little bit more work. You have to deal with fractions twice. In this case, you only have to solve one proportion to do it this way. 16 and 17 I know I went over a couple of these in class, but just a refresher. These ones are really fun to do and don't take a lot of work necessarily. They take a little bit of thought. So for example, number 16, I have two shapes going on. I have a square and a circle. I hope you all can quickly say the area of the square is 36 because it's 6 times 6. And then I'm going to look at this circle. It's like I'm going to tack on the other one on the bottom here to create one whole circle. If I know that the whole thing is 6, the radius is really going to be 3. So the area of the whole circle is going to be 9 pi. Again, the black part is if the whole thing was shaded is 36 pi. I'm cutting out a circle, so I'm going to subtract 9 pi from here. And I could leave it as 36 minus 9 pi. But I'm going to get a decimal just to show you. I'm going to first do 9 times pi. And you could use 3.14 if you need to. So that's going to give me 28.27 if I just multiply that in my calculator. So I'm going to take 36 minus that, and I get the area of the shaded region to be 7.73 centimeters squared. And there's 17. Now, we had a student point out why this problem doesn't work out very well. We're not going to go into that, but the problem is fixed. The reason it doesn't work out is this region right here, this 26 is too narrow. It's meant to represent a basketball court. Okay. So if I look at this, why it doesn't work out is because this should technically be a radius, but if you look at the radius is 13 here, this would really only go up to 13 then, which in this case you can tell it's already past that with this 15. Okay, so we're gonna do the problem as you would as if it were a half circle, even though it's not going to work out that way. The radius is 13. I just picked the worst color to use. Radius is 13, so if I wanted to find the areas, if it were a whole circle, I would get 169 pi divided by 2 because it's a half circle. Now I'm going to subtract off the parts that aren't shaded. The area of this rectangle is 120. And I have another half circle up here that is a radius of 4. So I get 16 pi as if it were a whole circle, but I only have half. So from that 169 pi divided by 2, I'm going to calculate that as a decimal. I get 265.46. I'm going to subtract off 120, and I'm going to subtract off 16 pi. Divide 2, which is 25.13. So I'm going to take my calculator, 256 minus 120 minus 25.13. Did I type something in? Oh, 265, excuse me. And I get 120.33. So with my rounding, I'm a little bit off from my official answer. But again, this problem is not logical because that really isn't a half circle based on the measurements we have provided. All right, we're in the home stretch. 2 to go because I'm not going to do the last one because I am not good at these measuring tools, and you should get around the area to be a 71. If you get a little under, that's fine. You get a little over, that's fine. By a little, I mean maybe 1 or 2 whole things, best, but nothing more than like 5 off, right? Make sure you're drawing in your heights very neatly. All right, so 18 and 19 are going to be our last 2 problems. And these are some of the best problems, and I hope that you all make sure you get to these. It says the ratio of one side of triangle ABC to the corresponding similar side of DEF is 2 to 5. So I have 2 triangles. All right, so I don't, this is not drawn very well because clearly if the ratio is 2 to 5, DEF has to be bigger than. All right, so we're going to draw that again. There's ABC. Now, this doesn't actually mean that the sides are 2 and 5. That means the ratios are 2 and 5. All right, so I know that my ratio of my sides is 2 to 5. And it's asking me to find the area of ABC if I know the area of triangle DEF is 58. So I know the triangle area of the bigger one is 58. So to go from sides to area, you're probably thinking, well, sides is 1-dimensional, area is 2-dimensional, so I need to square them. So I get 4 over 25 as the ratio of my areas. I'm now going to use that ratio to set up my proportion. So 4 over 25 is the ratio of the areas. 4 corresponds to the side on ABC, and 25 corresponds to the area of DEF, the ratio, right? So if I want to find the area of ABC, I'm going to put X, but I do know the area of DEF is 58. So then I cross multiply, and when you cross multiply, you should get the area to be 9.28 inches squared. Number 19 is virtually the same problem, except now it gives you the ratio of the areas, and they're going to ask you what's the ratio of the sides, and then they're going to give you a side and say find the length of DE. So the ratio of my areas is 25 over 64. To go back to my sides, if I square to get the area, I'm going to square root to get my sides. So I get 5 over 8 as my ratio of my sides. I'm going to use that ratio to set up my proportion. All right, so when I set up my proportion, I have 5 over 8. Again, that's ABC over DEF. So if AB is coming from the first triangle, that's going to go on top. And DE is coming from DEF on the second triangle, so that's going to go on the bottom. Cross multiply, I get 64 equals 5x. So x is going to equal 12.8 units. All right, so again, I'm not going to measure the last one. I would just draw in one to connect to the midpoint of this side and then connect to the midpoint of this side. And your apothem, to find your apothem, measure it, measure the side, find the area of the pentagon. And you can either break this one up into 2 triangles, or it's a parallelogram. So I'd measure this base and then I would draw in a height. And these are all the same parallelograms, so you can just multiply that by 4. I hope you are ready for your test tomorrow. Please come see me if you have questions. Good luck.